Hello everyone, I am Tang Yonghua. This course introduces the basic concepts of SDH Protection first, and then elaborates the principles of MSP and SNCP for better understanding of SDH Protection. SDH Protection is used to protect services in SDH networks. SDH Protection is classified into Multiplex Section Protection, MSP, and Subnetwork Connection Protection, SNCP. MSP is used to protect intra-subnet services, and it is classified into Linear Multiplex Section Protection, LMSP, and Ring Multiplex Section Protection, RMSP. SNCP is used to protect inter-subnet services. LMSP is used to protect services between two nodes. RMSP is used to protect services between nodes on a ring network. SNCP is used to protect inter-subnet services. The subnet may be a chain, a ring, or a more complex network. Different protection modes use different technologies and are applicable to various protection scenarios. MSP uses the multiplex section overhead, MSOH, bytes K1 and K2 in the SDH frame to transmit protocol information and control the transmit and receive paths of services. The MSP switching duration is within 50 milliseconds, meeting the international standards. MSP switching status that is commonly used includes forced switching, manual switching, exercise switching, and wait to restore, WTR, whose descriptions are as follows. Forced switching. Services are forcibly switched from the working channel to the protection channel. This operation is performed regardless of the protection channel status, unless the protection channel is serving a higher priority bridging request. For LMSP, if signals on the protection channel fail, the forced switching fails too. Manual switching. Services are switched from the working channel to the protection channel. If the protection channel is normal, the switching occurs. If the protection channel fails or is serving a higher priority switching request, the switching does not occur. Exercise switching. It is used to simulate a switching process. Services are not switched. It can also be used to test the MSP function without service interruptions. Wait to restore, WTR. If the switching due to signal failure or deterioration on the working channel is cleared and the working channel recovers within the WTR time, services will be switched from the protection channel to the working channel. The following slides describe the principles of 1+1 LMSP. 1+1 LMSP uses the dual-fed and selective receiving protection mechanism. Services are dually fed to the working channel and protection channel at the source end and selectively received at the sink end. LMSP switching can be classified into two modes, single-ended switching and dual-ended switching. In single-ended switching mode, if one working channel becomes faulty, switching occurs only on the local end rather than on the peer end. In dual-ended switching mode, if one working channel becomes faulty, services on all the working channels are switched to the protection channels. The following slides describe principles of 1 to N LMSP in normal and switching states. As shown in the figure of this slide, if working channel N becomes faulty, common service N on this channel is switched to the protection channel, and the extra service is interrupted. If multiple working channels are faulty, the service on the working channel with the smallest channel number is preferentially switched to the protection channel. 1-to-1 LMSP is a specific case of 1-to-N LMSP and is more simple than other cases. No details need to be provided here. This slide describes the differences and similarities between 1+1 LMSP and 1-to-N LMSP. The following slides describe principles of two-fiber unidirectional RMSP. Two-fiber unidirectional RMSP is implemented by two fibers, of which fiber S1 works as the working channel and fiber P1 works as the protection channel. Services on the ring are protected by diverse routes. The service path from node A to node C is different from that of node C to node A. When fibers between node B and node C become faulty, the service enters the protection status. Services from Node A to Node C are switched on Node B and Node C, and pass through Node A and Node C. Services from Node C to Node A are not affected. Two-fiber unidirectional RMSP has low resource utilization. An STM16 ring is used as an example. The working channel on this ring can only receive STM16 services. Currently, two-fiber unidirectional RMSP can be used in few scenarios. The following slides describe principles of two-fiber directional RMSP. Two-fiber bidirectional RMSP is implemented by two fibers. The first half of time slots of each fiber work as the working channel, and the second half work as the protection channel. STM16 two-fiber bidirectional MS shared protection is used as an example. VC4 time slots 1 to 8 are the working channels, and VC4 time slots 9 to 16 are the protection channels. Services on the ring use the same route. Services on the working channel of fiber S1 are protected by the protection channel of fiber P1. Services on the working channel of fiber S2 are protected by the protection channel of fiber P2. Compared with two-fiber unidirectional RMSP, two-fiber bidirectional RMSP has high resource utilization and meets the requirements of bidirectional services. You are advised to use two-fiber bidirectional RMSP. The following slides describe principles of four-fiber bidirectional RMSP. Four-fiber bidirectional RMSP is implemented by four fibers. Each fiber works as a working channel or a protection channel. Fibers S1 and S2 work as the working channels. Fibers P1 and P2 work as the protection channels. If working channels S1 and S2 in the west become faulty, span switching occurs and services are switched to the protection channels in the west. If working and protection channels in the west all become faulty, ring switching occurs and services are switched to protection channels in the east. Compared with two-fiber bidirectional RMSP, four-fiber bidirectional RMSP occupies more resources and delivers higher reliability. If fiber cuts occur on multiple spans on the working channels, span switching occurs and services are switched to the protection channels. When both working and protection channels are faulty, ring switching occurs. Four-fiber directional RMSP is commonly used in backbone networks with heavy service traffic. This slide describes the differences and similarities between different types of RMSP. This slide describes the definition and principles of SNCP. SNCP protects inter-subnet services by using dual-fed and selective receiving protection mechanism. SNCP uses a subnet as the working subnet and another one as the protection subnet. If the working subnet connection fails, or its performance fails to meet certain requirements, the protection subnet takes over the services, improving service reliability. Normal status. The working and protection channels are normal. The sync end selectively receives services from the working channel. Protection status. If the working channel that transmits services from Node A to Node B is faulty, the switching occurs only on Node B, which selectively receives services on the protection channel.